Hey everybody, happy Tuesday again. All right, let's close this down. There we go. So we got a couple things to talk about today. First off is Project 3. It's due tonight. A couple people said they had a little bit of trouble. I didn't hear from many people. Generally, I assume that's good, but now I'm guessing maybe that's bad. Again, please let me know if you're stuck on things. Generally before the day it's due. And I'm much more able to help and meet with you folks and do that sort of thing. So if it didn't go so hot, we've got options. One is just take the score as is and just keep on moving. We still have a fourth final individual project, which will be worth a couple more points than Project 3, because it will also use classes. If you want to attempt a alternate project, I'm open to that. But then that means you're doing that and the midterm and Project 4 and a final project coming up. So I'm not sure that's the best idea unless you really think you can knock it out of the park in a week and then still have time to do the next thing. So let me know. I think I've got most of the Project 2s graded. I might have missed a couple of them. I forgot to look here again. Thought I got most of them before we left last week. Let me see here. Yeah, we got 8 of them left. I'm sorry. So I did not get them all done and totally forgot about it here. So I'll get those other 8 in for you. Apologize for the delay on that. So we're going to do Project 3 tonight. We're going to do our arrays and the array list from the collections chapter. That's the only thing we care about is the array list portion of it. You'll pick up the rest of those collections in the data structures in class 2353 if you continue on. But we definitely need to know how arrays and array lists work. And then we'll do a little bit more review for the midterm. And again, for the midterm, I think I've got all this out here for you. We'll double check. I posted the practice midterm, which was last semester's midterm. I was going to have it be a timed exam, and I gave up on that because it's not really a good measure of if you can do something just because you can do it fast. So it'll open up just like the regular quizzes, except it'll be due by 6 p.m. the next week rather than 11:59 p.m. the next week. As I'd like it in before class starts so we can go over the midterm that day, the 26th in class, if that makes sense. So hopefully you weren't counting on that 5-hour, 6-hour window anyway, because you were assuming you were having to get it done that night. So hopefully no complaints there. So open up next week at 6 p.m. It's open book, open notes, open internet. Again, it is not open neighbor, right? You may not work with anybody else on it. It's your individual work, but you're allowed to use your resources, right? No developer in the world is told, please code this thing, but you're not allowed to look anything up ever. And it's all got to come out of your head because that's stupid, right? We have resources for a reason. I expect you to be able to use them. And again, that's more of what this class is about. You're getting a bunch of tools and techniques and ways of solving problems, and you have to apply those to solve the problems in the projects, right? That's sort of the idea. So you're learning how to do things, and you just need to figure out how you put those pieces together. So that's the goal for that. So ideally, low pressure is sort of the goal, and the research coming out says that if you feel like there's less pressure, you're less likely to cheat. Not that any of you folks would do that, but again, the idea is that you don't have that stress and that temptation that you have to get it 100% perfect in this 4-hour block of time. So take your time, start it, work on it, put it down, go to sleep, come back, pick it back up. I believe in all of you and think by this point in the class, if you're able to get Project 3 done, you should be perfectly fine. If you completely bombed Project 3, let's chat before you take the midterm and see what's not making sense, what's not clicking there. Because again, you are going to have to build a class as one of those long answer questions. It's not, all of the points in the world there, because it's 15 short answer style questions, quiz style questions. So that's half the test. And then the other 15 points are these 3 long answer style questions. Where's the scroll bar on this is terrible, right? So, hey, write the class is 5 out of the 30 points. So that's a large portion of the midterm is just being able to write a class given something. So if that didn't make a lot of sense to you, let's chat. All right, let's get together and figure out why that wasn't clicking right for you, because that's as far as this midterm covers, right, through classes. It'll do nothing with the arrays that we're talking about tonight. It'll be classes, methods, and loops. Again, not files. The previous book did files at the same time as it did loops for whatever reason. Sure. So don't worry about that. It'll just be do a loop to do something. Okay? Any questions, thoughts, concerns about the midterm coming up? And again, it is open book, open notes, so you're welcome to come in person. And if you'd like me to come and watch you, I would be happy to come and sit and watch you. Unless someone tells me that they want me to come here, I'm planning on not showing up. And I'm assuming all of you folks will, if you want, come and use the lab, go for it. Use the computers here, no problem. If not, do it at your convenience in a different location. That's perfectly fine. No, it's not this week. Sorry, Sarimo. Yeah, I've got it a little bit later in the semester. Just I wanted to make sure we got through enough of the content, essentially. Yeah, usually they're like week 7, so ours is actually going to be week 9. But again, sure, still sort of midterm. And then looking ahead to after that, let me go back here to our schedule. We only have a little bit of content left, actually, which is kind of crazy that we're looking into November will be the next time we start new stuff. So we have all of November is new stuff, aside from Thanksgiving week. So we'll do files, we'll do exceptions. Again, this is more of a topic you dig deeper into in the Java 2 or Object-Oriented Programming in Java course. I think it's necessary to talk about. We did a little bit of handling exceptions, right, with that try-catch block. We'll look a little bit deeper. We're not going to do all of the Chapter 16 material because you'll hit that again. So this will be a little bit of a lighter week, give you a chance to catch up, finish up Project 4, whatever you need to work on there. And then Java FX, everything from Chapter 17. And then I have more Java FX stuff I want to show you that's not in the textbook. Just cool things that you can do in Java FX. Again, you'll pick up more of it in 2151 as well. And then 12.7 is just set aside for you folks to work on the final project. Again, if you'd like to work in pairs, I think that would be a better experience. It does come with some extra work in that collaboration and coordination and figure out who's editing what and going back and forth. Our source control tool Git and GitHub make that relatively painless, but there's always hiccups here and there. But generally, any software project, if you're lucky, you'll be working in a team, and it's not you are the only one who does this ever, and no one ever else looks at it. That's generally not how things work in the world. So it's good practice to figure out how this collaboration thing works and how to talk to people. So that's just as I have nothing to talk about. I'll be here. We can sit the whole 4 hours and work on stuff. Ideally, you're done by 12.7, so you have nothing to stress about. Again, maybe that's not exactly the case. Maybe you still have a couple last-minute polish things to do. But then 12.14, we're going to get together. I won't be here on Twitch. We'll fire up Zoom. So anybody remote can present. They can do their screen sharing. You folks could even screen share from your laptop if you care to, or come up front. And it doesn't matter. You can clone your repository and hit run from here just as easy. And we'll all present our projects, which is quite interesting, I think, when you get to graphical user interface applications, like we're going to do with Java FX. There's so many different ways you can lay out the screen. You can have menus and buttons and things to click and places to type stuff. Nobody does it the same. And if everybody does it the same, I know you copied off of each other, because right, it just doesn't work that way when you're designing user interfaces. So it's just fun to see how everyone else laid out their project. So I'll give you an idea, like, hey, here's one way to do it, and a lot of people go down that road because they don't want to think of anything else, but some people have a lot of fun with it. So it's sort of interesting. And if you like that sort of usability thing, there's a whole field of study on human-computer interaction you can get into, which is definitely necessary because there are some terrible programs out there that people have to use, and they're awful. And we can do much better. So everyone claims Apple's really good at it, and I guess they are. But I personally just don't like Apple myself, but that's okay. No big deal. One big thing that it shouldn't bother me, but I'm old enough now that change bothers me, I guess, is that usually with menus, there's do you want to say OK or cancel? And there's 2 options. And for the longest time, OK was always on the left. I don't know why. It just was always on the left. And now the folks at Apple and people who do human-computer interaction research said, oh no, really the affirmative choice should be on the right. Okay, so now everything is slowly starting to switch over, and I just feel dumb when I get confused. I'm like, oh wait, oh no, it's not over here. So that's okay. Change is hard for people. We will get there. So that's looking towards the end of the semester. So tonight, and then really 3 more weeks worth of content, a little bit of extra Java FX stuff, and we're done. believe it or not. So we are cruising through. It's been a lot of fun. We're learning lots. It's going to probably feels like a fire hose coming at you, and that's okay. It's all new things. That's sort of the assumption. If you've been bored because you've done some programming before, I'm sorry. Maybe we can do a better job with placement and not making people be bored for a semester, but we can go from there. So any other thoughts, questions, concerns, schedule coming up? So we've got Project 3 tonight. We've got Chapters 11, just a tiny bit of 12 tonight. And then we've got midterm review tonight. So a couple things on the agenda. Okay, you folks are a quiet bunch. That's all right. That is okay. All right, let me fire up NetBeans here. We'll take a look at Project 3. So I'll pull up our description here. Now, the text description might have changed on you. I mistakenly created the assignment, and if you don't tell it that the default is it wants you to upload a file, because D2L assumes that you all would like upload a Word document or something silly instead of this text submission option. So I had to delete it and recreate it, but I forgot to copy what I had. So I had the rubric, and the rubric stayed the same, so I sort of like, I went from the description to the rubric, so now I had to go from the rubric back to the description. So if you're confused about something, hopefully you let me know, but we're going to build our little plane class for our autopilot here. Again, someone had a great point in the Discord. They said, well, shouldn't changing the altitude like automatically turn on or off the landing gear? And probably it should, like in real life, but like for our purposes, we want it to not, so we can return that false result and be like, hey buddy, something went wrong, false. That's all. Excuse me. Man, cannot get my sugar back down today. I don't know what's going on. Maybe that'll make it stop beeping at me. Okay, so we have the class, and then we have the unit tests here. So, and actually, I do want to show you an interesting approach here, which is, it's not the most common thing in the industry, but it's an approach to development called test-driven development. And the idea with that is that if you know what your code is supposed to do, you can write your unit tests first. And then your job is to make sure all the red X's turn into green check marks, which has the benefit of keeping you focused and on task and like, okay, all I need to do is this and make this work, make this work, make this work, make this work. If you start with the right class, it's easier to kind of stray off and be like, oh, let me also do this thing, or I'll also add the check for this, or I'll also do this other thing, which is all good things, but not possibly necessary. So test-driven development is the idea that once we've defined what's supposed to happen, we can write our unit tests first, and then we'll go make the code work. So it's kind of a fun approach. Let me get this opened up here. Come on, NetBeans. I should upgrade to 11 and just repave the whole thing, because this just keeps getting laggier and laggier, but I'm scared something will break, and then I'll just have to start all over again.
One of the classes, we have a group project for the, we use Discord for it, and the guy who's updated it to Windows 11 just randomly dropped from the call because...
Oh no!
So,
Oh, even like Discord just is not working? Oh, they're blue screening on 11? Ouch. Okay, maybe I'll hold off a little longer then. Or, I should probably just get a new computer that has Windows 11 on it. And that way, if someone does go wrong, I'll have this one here. Because I need to buy a new toy. It's necessary. And if it happens to run the latest and greatest games, then, well, bummer. I don't think this computer can run New World. I feel like it should be able to, but it has a hard enough time running some other games sometimes. It's got a decent graphic card in it, but it's 2.5 years old. Let's just reinstall everything. I have a friend at work. They will reinstall like every 3 or 4 months. Just get rid of all the cruft. I don't know. Seems a little extreme, but he's got it down to like a script. So he's like, okay, run the script, go get some coffee, come back an hour later, and you're back up and running almost. So that's kind of fun to automate things like that. All right, so again, for Project 3, I said, I don't care what's in main. We could care less. All we want is the class and the unit tests. If you wanted to put something in main to try it yourself like we used to do, fantastic. But what we're looking for is the class and the tests. So I'm going to come into my packages here, and I'm going to add a new Java class. We'll call this one plain. Now, before I can write the tests, I need to at least have the method stubs, right? The method needs to exist for me to test it, but it doesn't have to do anything. Is sort of the idea, is how you would approach this with test-driven development. So we're going to list all of our private attributes first, right? So we need a bunch of attributes for make, model, max altitude in meters, current altitude in meters, and a Boolean for landing gear enabled. Okay, we're going to have a private string for make, semicolon, a private string for model, private string for number, private int, probably an integer. If you wanted to do a double, that's fine, but I don't know if like half a meter matters when you're 10,000 meters up. So I'll do an integer. This is max altitude in meters. And again, when you have attributes that like represent some unit of measure, it's never a bad idea, or it's always a good idea, right, to include what unit you're expecting here, because otherwise they don't know if you mean meters or feet or miles or kilometers or inches or who knows what you're going to use here. And you definitely want to avoid any sort of conversion issues there. One of the first collaborative space station projects, we screwed something up because everyone else in the world uses meters and our engineers were too stupid to remember that. And we did something assuming it was feet and it just didn't work. Go figure. So sure. And we're also going to have an int for the current altitude in meters, and then a private Boolean for landing gear enabled, right? So true means yes, false means no, essentially. It's just a yes or no choice here, so Boolean makes sense for this sort of thing. Once we have that, then we can go to this insert code option and add all of our getters, right? We needed getters for everything, so yes, give me a get for everything. Now, you'll notice that the landing gear enabled is not a get. It's called an is, and the only reason for that is because it's is true or is false. So like the wording, the convention for that, if you named it get, that's perfectly fine. There's nothing wrong with it, but if you used this insert code option, you're going to notice it uses a different, is that a verb? Get? I think get's a verb. It uses a different word. We'll go with that, because I don't do English well. So is landing gear enabled, right, is true or false, is the only thing you might have noticed there. Now, we didn't have any sets, right? Get methods for everything, but no set methods. So we were going to have a constructor. Where do we say the constructor? That must be in here then, right? Yeah, the constructor accepts values and sets defaults for others. Okay, so that didn't translate over well. That's my mistake. So I think we had talked about in class, and if you didn't do this, that's fine because it's not in the rubric, that your current altitude should be 0 and your landing gear should be on because we build planes on the ground. That was sort of our default assumption here. If you didn't, that's okay because I'm realizing now it's not in the rubric, and if it's not in D2L, then that's my fault. Okay, that's fine.
Sure which one ended up in the line.
Yeah, that's all right. So you can do this insert code constructor, and you say, okay, I want to make, I want a model, I want a number, I want a max altitude. I don't need current altitude or landing gear enabled. And we're going to go that route. Again, if you did, perfectly fine. Don't stress about it. No big deal. So it sets values for all of them. Okay, and then I'm going to say my current altitude is 0. This would default to 0 because Java gives default values, right? It gives zeros to numeric values, and it gives false to booleans, and it gives nulls to anything that's an object. Don't rely on that. It's a bad habit. You want the constructor to explicitly set everything. That's a good practice, is that your constructor should give values to all of the attributes, right? Because if you're relying on a default somewhere and something changes, I don't know, it's just bad. Like, let's be explicit about it here. And it's one more line of code. And then also your landing gear, we want to set that to true to say when we're on the ground, our landing gear should be on. It would default to false if we didn't set it. That's the idea with accepts values and sets defaults for others. So you can't change the make, you can't change the model, you can't change the plane number. That might be possible in the real world. I'm not sure how that all works. Like when you register a plane, you get like an NC number or something or other, and they're all registered with ground control and all that nonsense. I don't know if it's changeable or not, but for us, we're not going to let you change it. Right? Once you make this instance a plane, it's a Boeing 777 NC 2007, I don't know, whatever numbers here, and it can go up to, say, 50,000 meters. That's probably wrong. Let's look up, what is the max 777 altitude? 3,500 feet. What is that in meters? In meters. Oh, geez. Okay, so that's probably 10,000 meters or so. Let's see, let me convert that to meters. All right, okay, so just over 10,000, almost 11,000 meters here. would be what our max would be. Again, if you gave it a realistic value. We don't, like, our code doesn't care what value you give it. We don't have a table in our code that says, okay, this make and model, here's your altitude. We're saying when you make an instance, you tell me, and my autopilot won't let you go any higher than that. Sure. In the real world, we probably get that value out of a database somewhere, right? Some sort of specifications database, but we're not there yet. Don't worry about it. Okay, so we have values then in our constructor. We accept the things that we want to give values to, and we default to the others that we don't. Then we have two more methods for change altitude and then either a set landing gear true or false, or a enable landing gear and a disable landing gear method. Either one, perfectly fine, whichever route you wanted to go here. So we're going to have a public Boolean change altitude given an integer of, I don't know, meters to change. Sure. And for now, I'm just going to return false. I'm just stubbing this out. I'm just going to put something in here. I'm going to come back and finish it later. I just want to get the methods out here. And then for the landing gear enabled, those ones we said we didn't need to return values, right? For let's see, let me double check. Okay, so it doesn't specify you need to return anything. Change altitude says we should return a Boolean. So I think for these ones, if you did, great. If you just had a void method, that's perfectly fine. No big deal, it just would not do anything. So let's do a void. How about enable landing gear or change landing gear status? I don't know. What do you want to do? Two separate ones or one method? One? All right, I'll vote for one. So let's call it enable landing gear, and we'll give it a Boolean for status. I don't know. Or I don't know. Change. I don't know. Is it change landing gear? That might make some change landing gear given a status like true to turn on, false to turn off. Okay. Yeah, that's fine. So again, this now doesn't need to do anything to just be a void method right now. Perfectly fine. So now we've got everything we need to actually start writing some tests. Again, this idea that we can do a test-driven approach. Some of it's actually going to work already because we actually did the rest of the constructor, but like the change altitude is not going to work, and that's okay. We're going to right-click our class and say navigate, go to test. Make sure we pick JUnit 4, have these 3 checkboxes checked, and we're good to go. Now, we don't need to test the get methods individually. Oh, good, they didn't even give us any. Look at that. That's cool. So if they had a bunch of get methods in here, testing all the gets, again, my idea with that is we're going to test it in the constructor. That's fine. Right? You don't need to do it separately because we're going to test that it all happens at once. So say app test, void test constructor, and we're going to do our AAA thing. So we're going to arrange, we're going to act, and we're going to assert. So to arrange, we need a bunch of expecteds. So we'll have an expected make, I don't know, Boeing, an expected model. We were picking on the 777, so let's keep it that. And then a string for expected number, I don't know, NC 777. It doesn't actually matter, right? Just whatever value we're expecting, we're going to get back out. And int for expected max altitude. Altitude in meters. I don't know, what did we say? It was about 10,677 or something like that. Sure. Doesn't actually matter too much. And int expected actual altitude or current altitude. Expected current altitude. That we are expecting it to be 0, and then a Boolean for expected landing gear status. We said would be true. We'd expect to have the wheels engaged when we're on the ground. Then we're going to act. What are we testing? Well, we're testing the constructor. So we'll say plane equals a new plane, given the expected make, the expected model, given the expected number, and the max altitude. Okay, we give it those 4 things. We call our plane constructor. We give it 4 things. It should set those 4 to the things we gave it, plus the current altitude and landing gear status. So then we're going to go use all those get methods to get the actuals. So we'll have a string for actual make, plane.getMake. We'll have a string for actual model, plane.getModel. Oops. And if you do this long enough, there's actually some auto test code generation NetBeans can do for you too. I'm not quite as fond of that initially, because like we should definitely go through the process several times. I like the auto-generate the get methods. So that seems a little silly to keep writing, but the test part, I like you to go through a couple times before you let the magic work. An actual number, plain.get number, and int for actual max altitude in meters, plain.get max altitude in meters, and int for actual current altitude in meters. Sure, if you're dropping in meters here, I'm not going to feel bad about it at all. Get current altitude in meters, and then a Boolean actual landing gear status. And then remember, this one is landing gear enabled to is because it's a Boolean, not a get. And then we assert they all equal. So we'll assert equal the expected make and the actual make. We'll assert equal the expected model and the actual model. Oops, need to make sure we give that to look at that. I had a typo there. I didn't do model there. That's nice. We have the expected model and then the actual model. And I'm just going to copy paste this line a couple times. 4, 5, 6 times. We'll go through all of our expected. So we get a model, then we do number, and then we have max altitude, and then we have current altitude. Remember, a double click will highlight the whole word for you here. So I'm just double clicking to highlight, Control C for copy, Control V for paste. Actual number, actual max altitude, actual current, and actual landing gear status. There we go. So now we got a test. Let's go ahead and run it. We'll test our file. Our constructor should work, right? We didn't actually have to do a whole lot there. There wasn't a lot of interesting code going into the constructor there. So this one should pass if we did everything right. All right, that one passes. Cool. Now the more interesting stuff then, right? We have a couple tests, right? We're going to have an at test for all the different scenarios of change altitude, right? And this is where we need to think through all the different things that can happen, right? If I try and go above the 100 meters and I have landing gear enabled, I should get back false. Okay, if I'm above 100 and I just increase my altitude, great, that one works. If I try and go above the max, that one also fails. So 3 different ways of going up, right? 2 should fail, 1 should succeed. And then for going down, right, going down below 100 without landing gear should fail, going down regularly should pass, and going below 0 should also fail. Again, I know sea level like differs in places, and that's not actually realistic, but we want to keep things simple, and we don't have a way of hooking up to, hey, what is sea level, or what is ground level for your given location? We don't have any way of looking that up now, so we're not going to bother with that. But we're going to have a couple different tests then. So we're going to have a void test change altitude increase or fail over 100 meters with landing gear on. Sure, look at that. Nice, long, crazy name, but you know exactly what this test is going to do. Right? That's sort of the idea. When we name a method, you should know what it's supposed to do here. Same with our test methods. So it's supposed to fail over 100 meters with landing gear on. Great. So we need our plane, but most of these values we don't care about anymore. So when we do our range, our act, and our assert, really we're only caring about a couple things here. So we need a plane to work with, okay? And we need to have where should the altitude be when we're done. So we said, hey, if I try and go up 1,000 feet and my landing gear's on, stop at 100, autopilot. Don't let them go above 100. Then, so our new altitude should be 100. So we're going to have an int for an expected altitude. Altitude equals 100. Great. That's our expected altitude. And then we're going to have a Boolean expected result is false. And really, we don't even need this one because you can just assert false. We don't need to say assert true, this equals this. Right? We can just say, hey, this should be false. So really, that's all we need here. And then we need a plane. So plane equals a new plane. And we don't care about the make. We don't care about the model. We don't care about the number. But I do care about the max altitude. Right? It just needs to be something larger than 100. Right? So like, sure, the 10,000 is fine. Okay? That's what we have a plane we're ready to act with. We don't care about those other values, so I just give them empties. They don't matter for us. Right? Then we're going to have a Boolean for the actual result, or just even result, I guess, right? This is just the result. Is my plane.change altitude. If I try and go up 1,000 meters, it should give me back false. And then I'll have an int for actual altitude, or actual current altitude. Because when I make a plane, I start at 0. Right? The plane starts at 0. If I try and go up 1,000, I should hit that 100-meter stop mark because my landing gear wasn't disabled. and autopilot should stop. So it should be the plane.get actual altitude, or get current altitude. There we go. Okay, and then we're going to assert two things. We'll assert false, my result, right? I should have gotten back false. That should not have worked. And then we'll assert equal, that the expected altitude is the actual current altitude. Okay? That makes sense? So we're saying if you start at 0 and try and go up 1,000, you're going to stop at 100, and our method should tell you false. Whatever you asked to do didn't work. Right? That was our test here for that, so it should fail. So when we run this one, it fails. It said, hey, it expected 100 was 0. Right? We didn't change anything at all, because our change altitude method does nothing. We didn't write it yet. So it's good that it's failing. Right? That's the idea. We're writing the tests, and we're going to go back and write the code to make them pass. That's the goal here. All right, then we need another test here. So we did the first failure, right? Then the second one should be a success. Right? This idea that we should be able to get to 100, turn off the landing gear, and then keep going. Right? So change altitude over 100 meters with landing gear off. So we're going to make sure we get over to 100 meters, turn off the landing gear, and then can we keep going up? So our expected altitude, let's just say 1,000. Let the plane go up to 10,000, perfectly fine. We'll go to 100, and then we'll, what is it? Something about landing gear. Change landing gear. We'll turn to false, turn off the landing gear, and then we want to go up again. So I don't actually need that Boolean here. I can just go up to 100. Go up 100, turn off landing gear, and let's go up the other 900 then. And then we should get back a true result. This should work. Should say perfectly fine. Yep, you can go up another 900 meters. And then we got to the 1,000 meter mark, right? Going up 100 plus the next 900 should get us where we want to be. Right? Again, this one will fail because we don't actually change anything at all. So we're still going to get back a 0. But this one should succeed. And our last one then, we wanted to test. Change altitude over max. Fails. So if we set the max at, say, 1,000, our expected altitude should stop at 1,000. We go up 100, turn off the landing gear, and then let's go up 2,000, or just something larger than our max here, right? We should get back a false, and we should stop at the 1,000 meter mark, which was our max altitude that we gave it.
Was it supposed to stop if the wheels were still you're still down at 100?
Yeah, it shouldn't go over 100 with the wheels on, with the landing gear enabled. So you'd have to get to 100, disable the landing gear, and then keep going.
Okay, so it's not like get there and then have to however hard they want to say.
So ideally, it just tells you false and doesn't go above it, right? The class just keeps itself from getting into an invalid state. That's part of this idea. We're encapsulating all those details. The class does not let you get over 100 if the landing gear is on. Right, so we can change altitude all you want. We're just going to keep giving you back false, 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 until you say, oh, okay, disable my landing gear, please.
Right.
Yep. So then if we try and go over the max, we should get back a false result, and we should stop at that 1,000 meter mark. Okay. Again, this one's not going to work yet, but I've written the test. These are the things that should happen going up. Now we have 3 more tests for going down. Right, a regular go down should work. Going down below 100 without landing gear should not work, and going down below 0 should also not work. Okay, so sure, we'll just copy this one, I guess. So let's say, how about below 0? Below 0 fails. So the expected altitude should be 0. We don't really care what the max is. If I try and go down 100, here we just need that Boolean result. There we go. We'll just say go down 100. We should get back a false, and we should still stay at 0. Right? You can't go below 0 for our purposes. Right? So we're going to say, okay, that was false. You can't go negative. No good here. There's one test. And then how about below 100 without landing gear on? Fails. So if we go above 100, we have the landing gear off, and then we try and go below 100, and we don't turn on the landing gear, it should also say false. So we should stop at 100 then. So now it's going to take a couple steps. This is a little bit awkward and silly, but that's okay. So we're going to first go up 100. And then we're going to disable the landing gear. Landing gear status, say to false, turn off the landing gear. And then let's go up another 100. Right? And then let's go down 200. That's the one we want to see. So I go up 100, I stop, turn off the landing gear, go up another 100. Great. Now from there, if I try and go down 200, it should stop at the 100-meter mark and say, nope, your landing gear is not on. You're not allowed to return a false. So that's the result we want to check. It should say, nope, that was false. Didn't work. You tried to go down 200. We said no. Autopilot's smarter than you are, Captain. Not allowed. And then we should have stopped at that 100-meter mark. Okay, that's the other fail. And we should have a regular success. So change altitude works. I don't know, or it goes down. Goes down. So if we go up, say 100 and go up another 1,000, and then we come down 5, let's go down 600, right? So if we go up 100, turn off the landing gear, go up another 1,000, then we come down 600. We should have been at 1,100, down 600 should put us at 500. Oh, we can't actually get up that high though, so let's make sure this is high enough. Our max is high enough. That would have been bad. It would have failed, but that's okay. We would have found something. So just to make sure I can go down a bunch of meters once we're high enough, right? And that should then, should assert true that that one works. Okay. Then we still need tests for the landing gear. So this is all the tests for the altitude. Now we still need tests for enable and disable landing gear. Okay, so let's do some of those. So test enable landing gear above 100 meters fails or does nothing. How about does nothing? Right? If you take your plane above 100 meters and try and enable landing gear, we're just going to ignore you and say, oh, you probably didn't mean to click that button. Right? We didn't need to bother with a returning true or false result. We just said, just ignore it. We don't need an expected altitude. We just need a plane to work with. We'll change the altitude. We'll change the altitude. And then we'll have a plane.enable landing gear. Change landing gear status. We try and turn it to true and turn it on. We'll get a Boolean for landing gear status. Plane.is landing gear enabled. And it should still be false, right? Once we've gone up this far, right? Us trying to turn it on should do nothing. So we should be able to assert false given the landing gear status. Right? The idea we got high enough, us telling it to turn it on, the plane's just going to ignore us because we're dumb. And then landing gear below 100 meters. So disable landing gear below 100 meters does nothing. So if we just don't move at all and we try and turn off the landing gear, it shouldn't do anything, right? It should still be true then, right? Our actual status should be true. Nothing should have changed with this trying to set it to false. Right? Okay. Then we want to test that if we get at the 100-meter mark, I can turn the landing gear off. Right? Making sure that this sort of thing works. So the way we're going to, I guess we don't know about the 100% code coverage because we haven't written the code yet. But we want to test that, yes, it does work at 100 meters. So disable landing gear at 100 meters works. Okay, so make a plane, go up 100 meters, change altitude. Now, it's a little bit silly because it's not a pure unit test at this point because it doesn't work if change altitude doesn't work, but we're still testing, does this method work, right? Which is still a good test. And it's still just testing the class itself. So then this should be false. It should work that we turned off the landing gear because we got to 100 meters with this one. Does that make sense? We're just trying to make sure all of our cases work here. And again, it would have had to have worked probably for this change altitude to work. But if we write change altitude first, no, I guess we have to write change landing gear first because we won't be able to do the altitude ones first. But let's see, we should get a bunch of failures, which is good. We want a bunch of failures. If you're writing a unit test and you don't have working code and your test passes, you should look at it a little funny. In our case, like changing landing gear below 0 fails. So our change altitude is just always saying false, right? We just had to put something in here. So sure, that one passes. Okay, I'm not going to feel too bad about that one because you had to have something in here for it to even work at all. So okay, don't feel too bad about that one. Where's the rest of our tests? Where'd it go? Test results. There we go. So that one passed. The landing gear below 100 meters does nothing. Again, it's we're always saying our landing gear is on because it never changes. Our landing gear is just stuck on because the only thing that does is the constructor says, yeah, landing gear is on. Never turns off. So, okay, so I think the test failures make sense. Now we can actually go write some code. So our landing gear status, let's do that one first, right? So we want to say if, how about if status, right? So if they're trying to turn it to true, right? That should only work, right? If our status and our current altitude is less than or equal to 100. If you're trying to turn it on, true, and you're at or below 100, sure, we'll say landing gear status, landing gear enabled equals true. Great. If you tried to turn it on and you're at or below 100, yes, you turn on. Okay? Else if your status was equal to false, right? Or you could say not status. Either one is fine, not status, or status equals false. They do the same thing. I think most people prefer the if or the not here because it's less typing. So if not status and our current altitude in meters is, what if we're greater than or equal to 100? Equal to 100? Then sure, we'll turn it off. Now we should never be 100 or more than 100 and go from on to off. But in this case, if you want to turn it off and you're at 1,000 meters, sure, we'll turn it off again. But like you already should be in the off state. So like you could just say if it equals 100 exactly, that's fine too. Not either one of these would have been fine. If it was just only at 100, that's fine. But I said 100 or less, sure. It would not change anything to say, hey, I'm at 0 meters, turn on the landing gear, because it's already on. That's what I'm trying to say. So then our landing gear enabled would be false. That's it for change landing gear, right? If you want to turn it on, you're 100 or less, great. If you want to turn it off and you're at 100 or more, great, it's off. Okay, now we can come back and run our tests. We go to test results. You can run all again here. You can rerun your tests. We should see a couple of them pass now. So disable landing gear worked. Our test enable landing gear 100, above 100 does nothing. So we can't change the altitude yet. That's why this one's failing. Because you can't actually make the plane go above 100 and make sure that it does nothing here. So that one's still failing. That's okay. We sort of need both of these things to work. But we're getting there. Actually, did none of the new ones? Maybe nothing new passed. That's okay. Because that one was already passing, wasn't it? Now we'll go to our change altitude. This is the fun one. Change altitude. Okay? So we had a couple cases here. Right? A couple things to check. So first we could check, are we going up or down? If we wanted to. We could say, hey, if meters to change is greater than 0, this is our going up case. Okay? If we're going up, let's see, where are we going up to? Right? So if we're trying to go up, we need to see where's our target. So how about we have an int for, I don't know, new altitude equals my current altitude in meters plus the meters to change. Okay? And then if the new altitude is greater than 100 and our landing gear enabled. So if you're trying to get above 100 and your landing gear is on, we're going to stop at 100. We'll take current altitude, set it at 100, and return a false. Right? That didn't work. You tried to get above 100, and you didn't turn off the landing gear. That was one case here. Right? Then we can also check for else if the new altitude is greater than the max altitude. Then we're going to stop. So say our current altitude then would equal the max altitude, and return a false. That was no good too. You got there, you got to max, but you didn't go as high as you wanted to. Otherwise, our new current altitude should probably equal the new altitude. Right? If we're not going over 100 and our landing gear's on, great. And if we're not going over our max, great, we should be in a good shape here. And we already checked, hey, this thing was positive here. So you gave me a number to go up. We should just take it. Right? I think that's the only things we cared about, right? If we were already above 100, we didn't care. Right? Or the landing gear should have been off if we're already at 100. So I think that's good there. And then an else case here. Well, so if it's not greater than 0, it must be less than, it must be negative. So again, we're still going to do the same thing here, which I guess is a little bit funny, but that's okay. We'll still have a new altitude, but when you add a negative number, you decrease, right? You go down. So sure. Then we can check if our new altitude, the new altitude is less than 100, and our landing gear enabled, if it's not enabled. Well, we're going to put our current altitude to 100, and we'll return a false. That was no good. Oh, this one we need to return a true, right? We should return a true result here. That worked, right? I forgot that one. So this failed. You stopped at 100 because your landing gear wasn't on, right? Else if the new altitude is less than 0, we'll take our current altitude, set it at 0, and return a false. No thank you. Stop at 0, please. Don't go below the Earth. Right? Again, I know in the real world there are places where the sea level and ground level are... yeah, sure. Doesn't matter. This is not the real world. This is just programming land. Right, then our last case here, right? So if you didn't go below 100 and had the landing gear off, if you didn't go below 0, then we can just set our current altitude to the new altitude. New altitude, and return a true. Okay, this should be good now. I know I typoed this new altitude here, so let me refactor rename. And fix that second L there. Altitude. There we go. And I'm going to repeat up here because that's going to bother me with that casing. So refactor rename. New lowercase l altitude. Okay. Now let's go back and run our tests. They should all pass. Uh-oh. They didn't. Let's see. Did they all fail? Holy cow.
Don't you have to, like, have a way for it to... Because if you're on the ground, your wheels are down. And then you're just going... And then if you change your altitude to, like...
Yeah, we should be able to get to 100.
Yeah, but, like, you change the altitude to, like, 1,000. You need, like, a way to just... like, off, right?
So if we're...
So if you go from 0 to 1,000.
It should stop at 100. So that's... So if our new altitude was 1,000, right? And our landing gear was enabled, we should set our current to 100 and return false. Let's see what failed with our tests here. Let's see. This is... I'm curious now. They all failed? Really? Let me... you know, I think... let me go back to the tests here and rerun test. You know, I think it's this project setting. I think it's my compile on save setting. Thinking that's it here. Let me change that. Because those all should have passed. Test the file. All right, now it says it's building. Okay, so now it's going through the build process. Got worried there for a minute, but I think this is good. Give it a shot. There we go. Now they all passed. Okay. Now I feel much better. If it actually compiles the new code we just wrote, our tests pass. And I feel like, and we can double check this now, do we have 100%? We have 100% code coverage. Do we have a test where this code runs? Yes. Do we have a test where this code runs? Yes. Do we have a test where this code runs? Yes. Okay, do we have a test where this code runs? Yes. Test where this code runs? Yes. Test where this code runs? Yes. Now, yours might not look like this. There's ways you could combine some of these, do them alternately. You didn't have to necessarily check where you're going up or down. There's like 5 different ways of checking for these conditions. Perfectly fine. So your 100% code coverage could look different if you just have 3 different ifs. Sure. Right? If you have 7 if, else if, else if, else if, else if, else if, else if, you're going to need 7 different tests. Right? However you wrote it, determines the level of testing that you need to get at 100% code coverage. That's the idea there. Does that make sense? And that's the plain class. Again, there was nothing needed in main here, right? Someone who wants to use our plane, great. They get to give us a make, model, number, max altitude, and they can make it go up and down. They can turn the landing gear on and off until their heart's content. We'll make sure they don't go above max. We'll make sure they don't go below 0, and they don't change that 100, go over that 100-meter mark without having your landing gear on or off, right? We're just setting up the code so that someone else can use it. That's the idea here. And then I can use this plain class if I wanted to write a flight simulator mobile game on Android or something silly. Sure. We could theoretically take this plain, or I could build a web application that uses this plain class and you could pretend to tell planes what to do. I don't know. That doesn't sound very exciting. But you could. Yeah. So there's a lot of things that planes autopilot actually do now, which is super cool. But we still need physical people in there in case the system fails. because computers do that. And apparently, I was just watching a video. It's really cool. I think it's Veritasium. You can like totally go down a rabbit hole with their videos if you like science stuff. The what is it? Cosmic rays can actually change bits in computer systems stored in memory as they come through. So like our space shuttle systems have 4 computers, and part of the process is all 4 computers need to compute the same thing before it says, yes, this is the correct result, because there's so much cosmic radiation that can change the bits being stored that bad things could happen if we don't check that and double check it and triple check it and quadruple check it. Which kind of freaks me out a little bit. So that's pretty crazy. So that's the neat side of physics, I guess. All right, questions, thoughts, concerns? Again, if you did not do well on project 3, that's not the end of the world. There are more points in the next individual project that it's good. If you totally tanked it and want to have a do-over, I'm open to an alternative assignment that can just replace what you did for project 3. The goal in my philosophy is that you code stuff to show me you can do these things. The idea of like demonstrating mastery of the subject. This is what classes and unit tests are. If you can demonstrate that, I'm good with it. Now, you're not just going to copy paste what I did, right? So you're going to have a different project that does different things. But that's sort of, can you show that you can write constructors? Can you show that you can write gets? This sort of idea. When I build these rubrics, they all sort of map, not all of them, but pieces of these map to the common course objectives. So in the syllabus, there's a big list of common course outcomes. At the end of every semester, not every semester, I don't actually remember how often we do this. At the end of every so often, we'll assess a given course across all the terms that it's been taught, all the different instructors who teach it. We'll say, okay, how many percentage of people were able to do this? And I have to say, okay, here was the assignment, here was the piece on the rubric that did it. And if 80% of you or more did it, or 70%, I forget what the metric is, we assume things are going well, right? Obviously, we don't assume 100% gets it every time. I think that's fair to say not everyone's going to get it 100%, but a good number of people get it. And we use that data for assessment purposes. So like all these things eventually will show up somewhere. Right? Write classes, create objects of that class with private data members, understand the concept of scopes, this sort of thing. That make sense? Cool. All right, so I got 7:02. I think we're due for a break. We'll take a break. We'll come back. We'll talk about either the midterm review or arrays in the array list in the collections class. Either one. And then we'll do the other thing. And then we're good, right? I think. Cool. So let's take a break. Let me put some more music on and go from there. Hit play. Hit play. There we go. Do this in the right order. So 10 minutes puts us out to 7:12 or so. Gotta go grab my Coke. I'll be right back. Alrighty, welcome back. Did you folks want to vote on what we should do next? The new stuff and the midterm review? I'm open to either. Doesn't matter to me. My choice? Sure. All right. Let's do the midterm review, because that is kind of wrapping up all the old stuff, and then we'll get into the new stuff. And this array new stuff won't be on the midterm, so hopefully that doesn't bother you. And that's nice that we're going to do something that you don't have to like absorb and retain and figure out how to get assessed on it a week later. I think that's the goal. I know sometimes it sucks to have new stuff in your head when you still have to get tested on the old stuff, but I don't necessarily have a happy middle ground for that. So hopefully this will be okay. And if you want, you could just ignore it and watch the video later after you do the midterm, I guess. So that is an option. So, all right, we'll do the midterm review. Now, again, the quiz questions, the ones on the sample here, are ones that I had written previously before I went to using the textbook test bank questions, which are slightly off, and I feel a little bit bad about it, but it's probably a good incentive to be reading the book, since you can get, oh, that's not the one I wanted, all the info out of the textbook for the questions there. So I've kind of talked myself into it. Where'd it go? Oh, here it is, midterm. So the quiz style questions, I'm not going to worry too much about, because you won't see this kind of question. You'll see the ones from your quizzes, which should all be open and you can see the answers. If it marked you wrong in any of those short answers, let me know. If your answer was close enough and you think you should have gotten the points for it, I'm happy to go in and correct it after the fact. I would just prefer not to look at all 20 or 10 questions of every 20-something people every week. So I'll leave that up to you folks if that's okay. All right, so a loop style question, right? Again, we're not writing anything to a file here, so just a loop that asks them to do something until they're done, essentially. Right? So if you have to write a loop that asks them to enter a bunch of things until they're done, that means we need some sort of sentinel value, right, for this case. So we'll need some sort of way of saying that we're going to be all done. So we could do a do while loop, because we're going to do it at least once, but I don't like do loops, so I'm going to do a while loop instead. So I'll say a string for class name equals nothing, and we're going to say while class name dot equals ignoring case, all done, or something, or stop, I don't know, whatever you wanted to put here, right? Some sort of value that is probably not the name of a class. So as long as our name is not all done, then we want to keep on going, and we'll ask them, please enter the name of your class. Hey, thanks so much for following along online with us. That's the name of your class, or all done to stop. Great, and then if we're getting some input, we're going to need that scanner here. So scanner keyboard equals a new scanner, given system.in. Yes, we want to import it. Thank you, NetBeans. And then we can say my class name is equal to the keyboard.nextLine. Okay, and then we'll get it. If it's not all done, we'll ask him again. If it's not all done, we'll ask him again. If it's not all done, we'll ask him again. So really, this is it. This 5 lines, right, is that sort of, hey, do a loop with some sort of sentinel value, right? That's all it is. Not anything huge here, right? So keep on prompting them for info until they tell you that they're all done, essentially that sort of thing. Okay, so you might have to do something. I'm not allowed to use the word class, Caramel. Okay, I think that's what on it, like for 5 minutes or something. I don't remember if there's a time limit for that. Let me see. What does it say? I really should know how long this is. Oh, yeah, for 5 minutes. Okay, for 5 minutes I won't say the word. Should be able to do that. It'll be fun for the next question. All right, next we'll write a method, plus minus multiply. It requires 4 integer arguments. Add the first 2 together, subtract the third, multiply by the fourth, then return the result of that. Now this one, order of operations is important, right? So plus minus multiply. We're going to write a method for it. So public static void, oh, I'm sorry, it's returning a result, so integer, right? It's going to return something, plus minus multiply. Needs 4 integer arguments. So first, int second, int third, int fourth. Okay, it said add the first two together. So we'll have an int for result is first plus second. Subtract the third, right? Then my result minus equals the third. And then my result times equals the fourth. Multiply by the fourth. Fourth. There we go. So that's one way to go about it. You can return the result. What you want to avoid doing here is you don't want to say return first plus second minus the third times the fourth, right? This would not be successful, okay? Because order of operations would multiply the third and the fourth together first, and then subtract that from the first and the second. That is not add the first two together, subtract the third, and multiply by the fourth, right? Does that make sense? So just watch out there, right? Order of operations needs to do something and return the result of that. Here, so this one is no good. So if you just do it in individual steps, perfectly fine, right? You're doing the steps, right? Now, if it wanted you to multiply the third and fourth and subtract that from the sum of the first and second, then sure, yes, this would be fine, right? That makes sense? So again, 5 lines of code, right? Between the header, then the 4 lines inside. And nothing huge here for that one. Is that okay? All right, and the last one, we're going to write a blueprint here in Java code for the flower here. It's going to have private attributes for name, color, smell, and number of petals. Add get methods for all the attributes. Add a method pick a petal, which reduces the number of petals the flower has, but does not allow the number of petals to go below 0. Okay, cool. So we'll write a class for flower. So I'm going to come in midterm review, in source packages, right click a new Java something file, call this one flower. All right, so we're going to have attributes, right? Private string for, what do we have? Name, color, smell, number of petals. Name, private string color, private string smell, private int number of petals. Right, we need get attributes for all of those. Not logger, sorry. I can't click. Insert code. Getter for all of them. Yes, please. All right, now we have get methods for everything. Now, 2 options here. It doesn't specify that you need a constructor or set methods. Right? It's up to you. Either one could work and would meet the spec of what has to happen here. Now, I'm going to default to using a constructor because I think that makes more sense. Right? There probably shouldn't be a set number of petals because you have this pick a petal method. Right? So if we have a constructor that takes these attributes, we'll just say, okay, once you have a name, color, and smell, those never change. I guess flowers could wilt technically, but that's fine. So we're going to do a constructor that takes values for all of those. We'll insert code, insert a constructor, say everything. Right, so you take a name, color, smell, number of petals, great. So now we have a constructor, so we can set those values. And then the last thing we need is public void pick a petal. Pick a petal, which reduces the number of petals, but doesn't go below 0. Right, so if my number of petals is less than 0, let's put number of petals back to 0. Right? Or you could check that first. Hey, if you are at 0, don't subtract 1. Either way is perfectly fine. Whatever approach you want to take, no big deal. Right? We could say, hey, if we're greater than 0, yes, we can pick 1. Sure. Right? Either way is okay. Both will make that work. But doesn't allow it to go below 0. Okay? So either we're going to reset it, or right, the other option, we could say, hey, if number of petals is greater than 1, I'm sorry, greater than 0, right? We could take number of petals minus minus. Right? Maybe that's easier then because it's one less line of checking. Oops, yeah, just delete that out. So we'll say, okay, if we have petals to pick one. If we don't have petals to pick, we don't do anything. That was it. And this one's a little bit more code, right? But a lot of right-clicking, insert code. Right? We had to define our attributes and go from there. How's that one feel? All right. Any other thoughts, questions, or concerns for the midterm review? That's that's it. Again, it was designed to be done in like a short sitting, but again, I don't want there to be that pressure of, oh, I have to sit and get it done right now, and then that sort of like writer's block sort of thing gets at you. So yeah.
You have to then go and then put it and then put it.
You could if you want to. All I'm asking for is the class. So if you wanted to write a main method to make sure it works, go for it. But the only thing I need you to turn in here is that class code here. Oh, I said the word. Uh-oh. Has it been 5 minutes yet? I might not be within 5 minutes. I said the word. Yeah, so all I need is the code for it here. Just that flower code.
Okay.
Yep. Yeah, if you want to test it, go for it. I mean, you've got the time to make sure that it does what you expect it to do. Go for it. I'm not asking for the unit tests either, because we have the project to go over the unit tests. So I just want to make sure we can write a class here given a spec. That's the assessment. Okay, so let me push that out here. This was our midterm review. Okay, then we can move on to some new stuff. I'll close this one down. So we're going to talk about arrays and array lists. All right. Close. Did I have more changes to it? I did. What did I have? I didn't hit save. Oh, goodness. Yeah, I needed that saved. Okay. It's weird. Let me close the project. Let me do this real quick. Let's have that. View again. I don't know. For some reason that wasn't saved. All right. Then we'll come back. So far, everything we've done, we've dealt with essentially individual variables, right? A variable held a single integer number or a single string or a single boolean or a single object, an instance of a class is still like one thing, even though it has a bunch of attributes. It's all been singles. And there's a lot of times where you want to have a bunch of the same kind of thing. You want to have a bunch of numbers or a bunch of strings or a bunch of this instance of this class here. So to do that, we use this thing called an array. So an array is a way of storing multiple values in essentially a single variable, right? So the idea is that it's going to make a holder. So let me open up, I think Word works better than my whiteboard. So I think the whiteboard was getting slow on the stream for some reason. Let me open this up here. Our new one. All right. So what you get with an array is you essentially get a contiguous block of memory. So like x329f here. And then you tell it how many items you want to put into this bucket. So if we're going to have an array of integers, it's going to go out, Java will ask the operating system, hey, I need room to store 10 integers. So 10 times the size of an integer, right? Integers were 4 bytes. It gives me 40 bytes of memory, right? From here to here, starting at x239f. Every 4 bytes is another integer. 5, 6, 7, 8, 9, 10. So I've got room to store 10 integers now in one chunk of memory. Now this is important that it's all in one chunk. This is what makes arrays different and a little bit funky here. Sorry, that's 40 bytes, right? That's 4 times 10 for ints. Okay. Now, when we deal with arrays, it's going to be really funny, and it's going to take a little while to get used to, but the first item in the array, the way we say, hey, I want the first item or the second item or the third item, we say, I want the index here in the array. So an array at index, and I say, okay, at this index or this index or this index or this index. And the funny thing is, indexes start at 0. So this is the array at index 0 is the first item. The array at index 1, index 2, index 3, index 4, 5, 6, 7, 8, and 9. So an array of size 10, right? So 10 ints has indexes 0 through 9. So you never have an index of the size of your array, right? Because we start at 0. So, and the reason for that is because this is stored in one contiguous block of memory, if you say, hey, I want the array index of 0, it says, okay, here's where the array starts in memory, and then it multiplies the size of your object by the index. So if you want index 7, it's going to say, okay, start at this memory address, add 7 times 4 bytes of memory, jump 28 bytes. So it will take 329F, add 28 bytes to that, and go read right from here in memory. That's why we start at 0, because 0, there's no addition, right? The start of the array is where the first object is. It's not all that important, but hopefully knowing why it does that makes that a little bit easier to remember. So our array notation introduces these square braces. Okay, square braces, square brackets, not the curly braces or curly brackets. We're going to use square braces, not even parentheses. So for an array, we say, hey, I want an integer array. So I say the square brace notation to say, hey, I want an int array. I'll call it numbers. And I say equals a new int array. And then how many items I want? I say 10. So we're using the new syntax, which is interesting. So usually we only do this for classes, right? When you want an instance of a class, you'd use the new keyword. You also use the new keyword when you're dealing with arrays. So you can have an array of any type. I can say I want a string array of words equals a new string array size 7. Nope, string size 7. Sure. I can say, okay, now I'm going to put 7 words into this string array here. Right now, because the indexes go from 0 up to, but not including the size, right? I can go and get at these values. Then I can say numbers, and then to say index of, we use the square braces again. I say numbers index of 0, I can assign it a value. 10, numbers index of 1, 20, numbers index of 2, 30, numbers index of 3, 40, right? Or I don't know, any values I wanted to give it, right? I can put any numbers I want in here. Numbers index of 4 equals 7, numbers index of 5 equals 0, sure, numbers index of 6 equals 1, 2, 3, 4, 5, 6, 7, sure, right? Numbers index of 7. So you give it the index value here inside of square braces. So it's an array variable index of, and you can set the values, or you can get the values. I can say, hey, numbers array index of 7 equals the numbers array index of 4. Right? I can get a value back out and then assign it here if I wanted. Right? I could say numbers array index of 8 equals 10 times 30. Sure, right? You can do arithmetic. It's essentially saying this slot in the chunk or the block of these values. So the index value is which slot do we belong in? Which location inside of this collection of 10 of them do we belong in? And then the last one, right? Numbers index of 9 equals, I don't know, let's say 0. Sure. We could set them to random values. It doesn't matter. Now, what you can't do is you can't say numbers index of 10, assign it a value. Now, it's not going to yell at us right now, which is really annoying because it should. There is no index 10 in my numbers array. Because I'm size 10, I have indexes 0 through 9. So when this runs, you're going to get your soon-to-be least favorite error message ever. Because this one will just plague you forever, but it's okay, it happens. Okay, let me run this again. If you try and access an array index that doesn't exist, you're going to get this error message. Array index out of bounds exception. This will be the bane of your existence while we deal with arrays. It means you tried to get at an index that doesn't exist. You did a bad thing. Right? Index 10 out of bounds for length 10. If your length is 10, you don't have an index 10, you have indexes 0 through 9. It's going to take a while to get used to. That's okay. It's going to take some practice. Okay, so we could get them values like this. If you know what the values are, the other notation you can use, which is really cool, you can say int array, I don't know, favorite numbers equals. You can cheat and you can give it in curly braces. I don't know why. I really don't know why here. We can do a bunch of numbers here. You don't even need to use the new keyword here, which is crazy. And this will create an array of the size of the number of numbers you give it here. So this is like a shortcut initializer, shorthand array initializer notation, or syntax. Probably syntax is the right word for that. So if you know the values to go in your array, you can just give them inside of curly braces. I don't know why it's curly braces, but sure. And it will set your array to those values. So this would be index 0, index 1, index 2, index 3, index 4, index 5. Okay? Once you have an array, we can loop through and get the values out. There's some cool ways to do some loops. So my favorite way, and the most common way you're going to see, is a for loop. And what we're going to do is we're going to set an index value. We're going to start it at 0, and we're going to go, now you can ask an array how long it is, right? You can say the index is less than the numbers dot length. So arrays have a length attribute that you can access. So the length is the number of items in that array. So the length of the numbers array is 10. The index, as long as it's less than 10, is a valid index. So it's always less than, never less than or equal to. Take index plus plus, and I can do something now with this index variable. I can say, hey, numbers at the index of my index variable, either do something, set the value, or get the value, or do something here. So let's just set up a sum. We'll say int sum starts off at 0, and we'll take the sum, we're going to add to it the value that's at the numbers array at the index starting at 0. Loop goes up. Okay, index 1, give me the sum, add to sum index 1, add to sum index 2, add to sum index 3, add to sum index 4, index 5, index 6, index 7, index 8, index 9. Then when index becomes 10, it is no longer less than the length. The loop stops. We didn't get an array index out of bounds exception. Right? So when we loop through, this is the most common way to loop through arrays. You loop through less than their length. Now, a lot of people, and it drives me nuts, but it's okay, they'll use the letter I instead of the word index, which, sure, perfectly fine. We know what everybody means if you say I. Not too big of a deal. My only complaint about I is that sometimes it looks like the number 1, and I get confused easily, right? If you look at I and a 1, like side by side, let me just like comment out, here's I and here's 1. Just at a real quick glance, those are pretty similar looking. Not like the closest thing in the world, but for someone who gets confused easily like me, I get confused. So if you write the word index, I know it's not one index, right? I know what index is versus an I versus a 1. So just do me a favor, because I get confused easy. I'm going to write index out all the time. That's all. And then if you remember back to loops and loops inside of loops, people do stuff like that. And for some reason, people like using I and then they use J. And if you put an I and a J next to each other, I get even more confused because they look even more similar than an I and a 1. And I just start scratching my head, and I have to look at your code and feel bad about myself because I get confused. So I would always recommend you use a nice long word, right? Like index. It's a couple more letters to type. So this is a common way to loop through the values in an array. Okay, there's actually, because this turns out to be a lot of typing, a shorthand. Go figure. We can say for int, we'll say number colon numbers, sum plus equals number. I need to only do another sum. 0, so I'll take another sum. So this is the shorter notation. And this might look kind of familiar to when we did the character array. We loop through one character at a time. This says, hey, for each integer, one at a time in this numbers array, give me one of them at a time. So for each value in numbers, I'm going to treat it as the variable called number inside this block here. I can do whatever I want with it. Now, this is a read-only loop, right? Because when you do this notation, you're getting a copy of number. You're not able to change the value. When you're using the index notation, you can change the value stored at that index. It's an important distinction there. So just be careful, right? If I were to reassign number, it's not going to change the numbers array. In here, if I say numbers at an index and I change the value, it will change the array because you said, hey, change the value in the array at this index. You got to be a little careful there. All right, so if we say, hey, I want some words, let's change this up. Let's ask the user here. So let's make a scanner, call it a keyboard equals a new scanner equals a new scanner given system.in. Oh goodness. Yep, add our import please, NetBeans. Yes, please. And then we'll ask the user, hey, how many words do you want to enter? Okay, and then I'll have a int for number of words is equal to an integer.parseInt of the keyboard.next line. Great, and then I can make my array size of number of words. Right, this number here, your size here, doesn't need to be fixed. Oh, sorry, I still have the music on. Is that too loud? I can just turn that off too. I forgot that was on until I heard that. So you can size the array based on a variable. Right, so I don't know how many words they're going to be, but we'll go for it. And then I can say, you know, for index is 0, index is less than the words.length, index plus plus, and let's say enter a word. And then my words at the index, I can assign the value of keyboard.nextLine. Right, whatever they type in, I'm going to save to the word's index. So index 0, they enter a word, great. Index 1, enter a word, great. Index 2, enter a word, great. Now, what happens behind the scenes when you store an array of strings? Remember, strings are objects. They each live at a different memory address. So when you say, hey, I want to store, let's say 7 words, right? I get 7 blocks, 1, 2, 3, 4, 5, 6, 7, and each of those is 8 bytes, right? Because that's 64 bits. I have a 64-bit system. So my memory is addressed in 64-bit chunks. So what's stored here is the address of where that string is in memory, right? So right off the bat, I'm going to get null, 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 because it doesn't point anywhere. There are no strings in memory. And then as I go assign them, it will say, okay, here, this string is at, you know, x2392, this string is at x74ba, right, on and on and on and on. We can start assigning it and say, okay, this is where the string lives in memory, but the addresses for those strings are stored in one block of memory in this array, right? Because an array stores a contiguous group of variables. Same thing works if I wanted to make an array of objects. I can make an array of my plane class, right? I don't have the plane class in here currently, but it would be a plane array. Nope. Plane array. Goodness. Okay, it doesn't like it because I don't even have it. Plane array. Planes equals new plane array. Right? That sort of thing. So you can have an array of a type of object if you wanted. And this would be, hey, all the planes that my air traffic control has to care about. Right? That sort of thing. Now, the downside to arrays is that once you say an array is this size, it cannot be changed. So I probably wouldn't actually want to use an array for traffic control because new planes come in and out all the time. And if I can't add new planes, I'm going to be in sad shape when a plane wants to come land at my airport. I'm going to have to say, no, there's no room for you, right? So arrays are rather inflexible, right? Once they're sized, they're stuck. But we get at things by index and we get their value. So let's give this one a shot. And then let's just print out. So let me print the words array here. Let's give this a run. We'll ask for some words, or how many words do we want to enter. Oh, that's right, I forgot. We still have that array index out of bounds exception. This is bad. Array index out of bounds exception. Okay, let me give that a run. All right, how many words do we want to enter? How about 7 words? I'm hungry right now, so how about an apple, banana, a carrot, a donut, some eggplant, fried chicken, and ghost pepper. When you output an array, it's ugly. It says, hey, it's an array of type string at this memory address, right? Not a great output, right? Pretty ugly. But what we can do is we can loop through it, right? We could say for string word in words, we can print out the word. Right? That's much prettier, a much better output here. So this is junk output, essentially. But now I should get back out the things I entered. Again, sure, let's just say, let's do like 3 words. We'll do apple, banana, and carrot. And I get apple, banana, carrot. And then the junk output again. It's just garbage. That part makes sense? So we can loop through them and we can output them. We can do things with them, right? But if we're using this sort of loop, it's read-only. I can't change what's in the array. If I wanted to go and change the values, I would use a loop using the index, and I could do something with it here, like I did. I can change the value, what's stored here, because I'm accessing it by index. Again, this is read-only. Sometimes known as like the enhanced for loop. You might see that called. That's using an array. How's that feel? It's a little funky. The syntax, the notation will take some practice. Our next project will be dealing with arrays and files, I believe. Right when we get back to the midterm, it was arrays and files. Let me double check. Let's see. I think it was files. And then we did exceptions after that, right? Yeah, arrays, files, and then we'll do a little bit more with exceptions, and then we'll do our Java FX stuff. So the next project will be arrays and files. It'll be a lot of fun. And by fun, I mean you'll be writing code, which hopefully doesn't seem terrible, because I'm assuming you're sort of interested in it, given the fact that you're in this class. So, all right, we close that down. I don't need to save it. Okay, so we can loop through them. Now, arrays, because they cannot be resized, right? You can't make them smaller, you can't make them larger. You have 2 options. The first option is you make a bigger array and you copy everything. Right? So if we wanted to make the numbers array larger here, we could do that. We could say, hey, I'm going to make an int array for new numbers equals an int array of size 20. New int array of size 20 with that new keyword. Then we have to go through and copy. Then I'll say for int index is 0, index is less than my numbers.length, index plus plus. And now the index notation here is important. I can't use that enhanced for loop because I'm going to use index for both arrays, the old one and the new one. I'm going to say new numbers at index is equal to the numbers array at index. Right? Let's copy it. Take what was in the numbers array, copy it to the new numbers array. Right? Copy, copy, copy. One at a time until I've gotten all of the ones out of the old numbers array. Now there is a shortcut, shorthand notation, and I can never remember the syntax for it. It's Java arrays copy. I just have to Google it here. Goodness, give me a decent looking website. None of these look like they're geeks for geeks, I guess. They're probably not terrible. I was looking for like Stack Overflow, but that's fine. So to make the copy, you import java.util.arrays, and then you can make a copy of notation into a new array. So this is nice. So you don't have to do the loop yourself. You can use arrays.copy, copy of, if you want. Sure. That's one option. It's not too hard to do the loop, right? To loop through, but it's if you can do something in one line that someone already did for you, you don't have to reinvent the wheel. Right? But I can't make that numbers array larger. But then what I can do, then I can say, hey, my numbers array equals the new numbers array. So I can't just say numbers equals, so if I said numbers equals a new one, numbers equals new int of size 20, right? As soon as I do this, and I say new integer array, I lose all of these values. So this is no good, right? This would be very bad here. So it would lose all the old values. So you don't want to just say, hey, it equals a new one. You need to make the new one. You need to copy them over. And then if you want to, you can say, okay, hey, now you point at this new thing here. right? And then if I were to actually print these out here, if I were to print out numbers and print out new numbers, you're going to see, because remember what it gives you is the memory address of where these things are stored. One word, ASDF, sure. You'll see, hey, they're integers, that's why it's an I for some reason. They point to the same memory address. So, oh, that's the wrong one, sorry. NetBeans, yeah, NetBeans. Wrong page, here we go. So if you say this array equals this array, now if you modify either one of those arrays, you're modifying both of them. This does not make a copy. It says, hey, this array points to the same location as this array in memory. They both point to that same block of memory with this many values inside of it. So if you change one of them, you're changing both. So it's not a great copy doing it this way. That's probably the arrays copy is a little safer, because if you then take new numbers and do something with it, you've also messed up numbers. Just be a little careful. So now we have two variables at the same location in memory. You gotta be a little cautious with that. All right, so we can do the cool new ones. Let me double check here real quick, make sure we're not missing anything. Before we move on to array lists. It's actually one other thing I'll show you for sure. Let's see how far this gets. Oh my goodness. I don't even remember what yeah, chapter 11. Okay, that's what I thought. Chapter 11. Actually, I thought 10. That was wrong, but it's 11. Make sure we're grabbing all the right stuff here. Oh yeah, so other ways you can declare arrays if you want. You can say int new numbers array equals new int array. So the array notation can go on either the type or the variable name. Most people, if I recall, do it on the type. But either way is perfectly fine for your notation, no big deal. Yeah. Clearing them, setting them, great. Notations, initializer, yep. Looking good. Sums. Yep, cool. Yeah, arrays copy. Yep. If you ask if two arrays are equal to each other, right? So if I didn't do this here, so let me stop this for a second here. I've made a copy essentially, but new numbers is larger, so they're not going to be exactly the same. But if I were to make it like size 10, make them have the exact same values here, I would say if new numbers equals numbers, the arrays are equal. Else the arrays are not equal. So if we run this here, and we copy all the numbers from numbers into new numbers here, they're the same size, right? Perfectly fine. One word, SDF. The arrays are not equal. Because what equals checks here is, are they the same memory address? And they're not the same memory address. If you want to check if they have the same contents, we have two options. One is doing it by hand, and the other is using the array equals method here. So we could say if new numbers, it's arrays dot equals new numbers, comma, numbers. And then we have to add our import for arrays. So arrays dot equal will compare the contents. So if the contents match, right, does the first item match? Does the second item match? Does the third item match? Does the fourth item match? It's nice to have that shortcut, but to do it the other way, right, we could say for index is 0, index is less than the numbers dot length, numbers dot length, and really we also want and index is less than the new numbers dot length. Dot length. Right, you want to make sure that you're less than both here essentially. Index plus plus. We can say, hey, if the numbers at index does not equal the new numbers at index, we'll print arrays do not equal, and then we can break the loop. So sure, we can use the break keywords and stop the loop. We found something that didn't match. Otherwise, we're going to go all the way through, and if we have not done that yet and we got to the end, right, then we can check one last thing and say if the numbers.length equals new numbers.length. Right? I guess we should check that first, right? So we can check all of the items and then make sure it's a little more complex, right, to loop through. But essentially, we're looking at each individual one here, right? So the arrays equal will do that same comparison for us. Make sure they're the same length and they have the same contents. Will give us back a true or false result. Now, you can write functions. So here we go. This would be better as a function, actually. Let's do this. Let's do our own function. We'll have a public static boolean do arrays match, and you can have an array as an argument. You can int array first and int array of second. So say, okay, you give my function, my method, 2 arrays here. We're going to check, hey, if the first.length does not equal the second.length, we're going to return false, because if they're not the same size, game over. You lose right off the bat. Then we'll go through and we'll do that loop, right? And if we find one that doesn't match, we're going to return false. That was first and second here, right? So this is first. And now, if I know the length is the same, this is a little safer, right? I can just go up the length of 1. So first doesn't match second, we'll return false, right? So we're going to check, okay, if the lengths are not the same, false, and then if we find one that doesn't match, false. If we've gone through the entire array, right, from start to finish, every index, and they all match, they all equal, right, then I can return true. Return true, yes, my arrays match. So this is doing our version of arrays.equal, right? Of arrays.equal. Equals? Yeah, arrays.equals. Now, what's interesting, though, this is an integer array. And an integer array, the arrays equal can be integers, can be doubles, can be anything. Right? It's a little bit smarter here. Again, you'll work more with that probably in the data structures course. But that's probably enough for us, for our purposes here. Yep, so we've got that one. The arrays can sort, which is pretty cool. There's an arrays.sort. Sort given an array object. Right? You can give it an array of integers and it will sort it, which is really fun. Doing that by hand is a little harder, again, beyond the scope of what we're going to do. You can learn simple sorts and data structures, but there's a lot of stuff built into the array class itself, which is fun. Yeah, cool. All right, then the last thing I want to show you about arrays, and then we'll move to array lists, is kind of a funny thing. So we said, hey, this array is a type of integer. Right? I'm going to have one block of integer arrays. The next thing you can do to take this to the next level, we find main here, I can say I want an array, right? So an integer array of arrays, where in memory then, my word here, I want an array of integer arrays. So what that says is, hey, I need a block of memory here, and each one of those is going to store its own block of memory, right? So typically, when we look at, this is called a two-dimensional array, you'd imagine this as rows and columns is kind of the easier way of thinking of this. So it's one big array here, where the first array is the first row, the second array is the second row, the third array is the third row, right? So it's row, and then you have column. So all of these rows here, this is index 0, this is index 1, this is index 2, and then inside of each of those is column index 1, or 0, column index 1, column index 2. Right? So this would be a 3 by 3 array. Right? 3 integers, 3 more integers, 3 more integers, like that. So you can do a two-dimensional array because what's being stored is a bunch of integer arrays in an array. This will be my 2D dimensional array equals a new int array of, we'll say, 3 by 3. So you can think of it as rows and columns here. Hey, thanks so much for following along with us online tonight. So to get at the different values then, I would say for int, now I'm going to say row index is 0. And this is where people use I and j, and it drives me crazy. So row index is 0, row index is less than my two-dimensional array dot length, row index plus plus. And then inside of that, now for every row, I want to say for int column index starts at 0. The column index, now I know it's a 3 by 3, but you can also have rectangular shaped or even uneven shaped where like one particular row is a different length than the others. So the safer way then is to say it's less than my two-dimensional array at row index dot length. Remember, because the thing at the row index is an array inside of that. So I go off the length of that, take my column index plus plus. And I can get out every individual value. Now, if I just print all the values out, it's not going to look like a two-dimensional array. So what I want to do is I want to print the items without the new lines in between. So I'm going to just use a print instead of a print line. I'm going to print my two-dimensional array, and then I use at row index here, at column index. And then I'm going to add a space here. Right? So it says, okay, at row index 0. So row 0, give me column 0. Row 0, give me column 1. Row 0, give me column 2. Great, move to the next row. So once I've done all of the columns, then I want to print that new line character to go down a line. So I'm going to do like a comma to separate them here. Okay? So we're going to loop through every row index and every column index within that row. We'll loop through and print it out. So when we start a new array, we get default values, so it's all zeros. No big deal. So when we run this, we should get a bunch of zeros, but it should look like a two-dimensional array, which is fun. 1, SDF. Okay, so we see, right, 0, 0, 0, 0, 0, 0, 0, 0, 0. So we see the first row, the second row, the third row. Row index 0, row index 1, row index 2. So this is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Right, that's how we would get it, though. So two-dimensional arrays are really cool. You can do three-dimensional arrays. It starts to hurt my head at that point, where you have rows and columns and like depth within those. If you ever get to 3 dimensions, you're probably doing something wrong, because there's probably better ways to store that information. But you can go to 4 dimensions or 5 dimensions or 6 dimensions and just go nuts. Honestly, beyond 2, I start not being able to understand it. I can vaguely understand 3. Right, where you've got the row, the column, and then the depth that you're working in each time. But it starts to get nuts at that point. So I try and avoid it if I can help it. That's two-dimensional arrays. Okay, you want to power through and talk about array lists, or do you need a break first? I can do either. Nobody has an opinion? All right, we can just keep going. It's probably another 15 minutes or so with array lists, and we can call it a night. Work on practicing stuff, work on prepping for the midterm. And we're not tackling the next new project yet, so there's not a whole lot on our plate aside from the midterm, which should be nice. All right, so sure, we'll do array lists next. So, sorry, fuzzy's stuck on me or something here now. Now, arrays are great. They can store multiple things, but they're not flexible. So, turns out it would be nice if these things were flexible. The fine folks at Java wrote the ArrayList class for us, which is flexible. You can expand it and contract it. So, to make an array list, now the syntax gets a little funny here again. That's okay. It's ArrayList, and then in greater than, less than brackets, you say ArrayList of type. Now, type here is funny. I can't say int, lowercase int. So ArrayList only work with objects. Now it turns out we have this integer class that wraps the integer primitive type perfectly. So you can only make this of to use classes, no primitives. So if you want doubles, it'd be capital D double, capital I integer spelled out, not just int, capital B booleans, those sorts of things. You have to use classes. This will be my numbers list equals new array list. And then the fine folks at Java said, hey, if you typed it once, you don't need to type it a second time. You can just use empty diamond. They call this the diamond operator here. And then a set of parentheses. Holy cow, lots of notation here. And then yes, I want to import java.util.ArrayList. The ArrayList class comes out of the utility package, just like scanner does, just like random does. There's all sorts of cool utilities in the utility class. So there's nothing wrong with putting integer in here, but it's going to warn you and say, hey, it's unnecessary, that you don't need it here. Okay, it says redundant type argument, use diamond operator instead. So you don't need to put it there, but you do need the parentheses, because this is calling a constructor. Here, ArrayList is a class. We're calling the constructor method here to make an instance of the ArrayList class. Okay? Now, if you know the size, you can put in the size here as an optional argument. I can say, hey, I know I need 100 things. Size it at 100. It'll make it a little bit faster for you. If you don't give it a size, it defaults to something, and I don't actually know what the default is. Might be 10, but I'm just guessing. So we don't care. For our purposes, it won't matter. When you get to the data structures course, that will matter, and you can look at why it's fast and slow and that sort of thing. But for our purposes, we're just happy to use it. So now, numbers list, you get a numbers list. If you say dot, you get to see all the cool things you get. We like this add method. Add says, hey, add an integer. It will add it to the end of the list. So I can add, say, the number 10. So adds to the end of the list. There's also another add you can do. There's an overloaded version of add. So numbers list dot add. And you can say, hey, I want to add, where'd it go? Add dot add. There it goes. If you tell it what index you want to add to, it will insert it into that index. I wish it was called insert instead of add. So it'll say, hey, if you want it to be the new index 2, it will put it at index 2, which is pretty cool. So you can move things around and everything else will slide to make room for it here. But that's fine. So it'll give me all the numbers, right? So add, and then to get a value out. My goodness, where's that? Why am I not seeing it? So dumb. Hang on. Yeah. Well, okay, why was it not there? You call .get to get a given index out. So get index 0 will go and get the value at index 0. So gets the value at index 0. And then if you want to change the value, numbers list, you call set here. Set what index? Set index 0 to 42. Sets the value at index 0 to 42. Right, so our array notation for that would have been my numbers at 0 equals 42 would be the set notation. The get notation is just numbers at index 0, right? So it's a little bit wordier because we're using methods. It's a class, so you're using the get method, you're using the set method, or the add method here, right? The add, there is no equivalent. There is no way to add to the end of an array. It's impossible because arrays can't be resized. An array list will resize itself. If you get to max capacity and want to add another thing, it'll say sure, and it makes itself bigger. There's all sorts of cool stuff that happens behind the scenes for that. So you can add values to the end of the list. You can get values by index. You can set values by index. Now this will also cause all sorts of problems here. If I call set, like numbers list, set index, 5 to the value of 20 here. The only thing I've added is one number. So its size is 1. There is no index 5 right now. So let's run this real quick. Enter one word, sure. You get index out of bounds exception. So it's not an array index out of bounds, it's just an index out of bounds exception. Right? Index 5 out of bounds for length 1. Same thing that we got with arrays. Right? It's just going to crash real hard on us. So you got to be careful again that you don't try and get a value that's out of bounds. So looping through this, let's add a couple more here. So let's add numbers list dot add 20 and numbers list dot add 30. Sure. We'll loop through a couple. So two options, right? We can use the index loop and we can use the enhanced for loop. So we'll do them both. So we're going to say for int index is 0, index is less than. Now my numbers list, it has a size method. It doesn't have a length method. Makes me sad. So array lists have size, arrays have length. I wish they were the same thing, and it irritates me that they're not, but that's okay. I'm just particular. My index plus plus. Oops, let me bring that curly brace down. There we go. And we can just print out, right, the numbers list, get the index, right? Get is the, you get the value, or we could set if we wanted to set it here, but you can loop through the size of it here and get out numbers one at a time. With the enhanced for loop, it looks the same way as the other one. We're going to say for int number colon numbers list. Print out the number. Right, so this is even easier with the enhanced for loop. Right, you don't have to use any of the method notation. It just gets your numbers out one at a time. We should get 10, 20, 30, right? 1, 1. We get 10. Oh no, 42, 20, 30. That's right, because I changed it. Sorry. So we get 42, 20, and 30. I added the 10, and I went and I changed it to a 42. So 42, 20, 30, 42, 20, 30. Right? Both loops will output the results. One using the index and the get method, the other using this enhanced for loop. Right? Again, this is a read-only loop. Read-only loop. This is important. You got to remember that when we're dealing with values. Right? We can't change them here. Okay, so that's an array list. Now, if you wanted to make a two-dimensional array list, right? The syntax is funny. It's an array list of type integer. Two-dimensional array list here equals a new array list diamond parentheses. Now, you don't have to give it the double diamond, right? Because what's being substituted is array list of type integer again here. Now, for each one of these, you'd have to add a row then. So for two-dimensional arrays, we'd want to add a new array list of type integer, right? For each row. This will add a row. Shoot, was it add? Add. Oh, sorry, two-dimensional array list. There we go, dot add. Okay, I was using the two-dimensional array, not the array list. And I can add a new array list here, and sure, okay, yeah, I don't even need to tell it to type integer, it just knows. It's smart. So I can add a row, and then I can take my two-dimensional array list, get index 0, will give me back the array list, and from there, then I can add 10 to it. Right, so this will get the row 0, and we'll add 10 to row 0. Right, so this adds row index 0, and this adds 10 to the array list at row 0. Right, so they behave just it does the same thing, but the notation for it gets really funky because you have to get the array at the row, and then you can add to it, or you can get from it, or you can set from it, that sort of thing. So the syntax there looks a little funny. Now, I am going to almost exclusively prefer array lists, purely because you can add to them, and you don't have to worry about having to resize them. They resize themselves. I'm going to say they're just always easier for developers to use. Now, arrays are technically slightly faster, so sure. Have at it. We don't care about fast in this class, right? We just care about works, and we care about let's make it work easy, right? We want the easy way out. We want to be good, lazy developers, and that we don't want to have to do more work than we need to. So if I use an array list, I can add to it if I need to. Great. I'm not stuck at, oh, I can only put 10 things in here, and if you want to give me 11, oops, I have to go do a bunch more work now. Make a copy and make it larger and all that sort of thing. Array lists do that work for you behind the scenes. So anytime I need to store multiple of a type of value, I'm going to go to array list and say, oh, okay, I want an array list of that type. Now, you can't mix and match types. They can only be integers, right? Everything in it has to be an integer. But you could make a list of plain, right? I can have an array list of type plain and put a bunch of planes in there, like air traffic control. And then if a new plane shows up, I can add it to my list, which would be great. And I can loop through and see, okay, where's this plane? How close is it? Does it need to land? And do all sorts of manipulation. So the array list class gives us that flexibility that now maybe we can actually use and model some sort of air traffic control for all of our planes. That sort of thing. Although we probably need their GPS coordinates to make sure that none of them get too close to each other, because they have rules about how close planes are allowed to fly to each other, and that sort of interesting thing. It's pretty neat. So there was a story a while ago. Planes don't actually use GPS or something. They used some sort of different positioning system that's this older style. And because it was older, the rules around it were like you had to be within more than, I don't know, like 3 kilometers away from any other plane because this coordinate system that they were using was not as accurate as GPS or something. And if we could use GPS on our planes could get within like a kilometer of each other because it's much more accurate. And then we could be more efficient at our ground control and landing and takeoff and things like that. Apparently, modernizing our plane infrastructure is wildly more difficult than you'd expect it to be. Upgrading technology is hard, at least when you're dealing with people's lives. So maybe it's a good thing we're taking it a little slow, but it seems a little silly. Okay, thoughts, questions, concerns? So arrays and array lists for storing a bunch of something of one type. And we'll use them, we'll make use of them when we do our last individual-based project. Lots more examples in the book you can go through for sure. Lots of really cool things you can do. Just add another tool to your toolkit here. So another way of storing. So right, if we wanted to store 5 numbers, previously we'd have to have int number 1, int number 2, int number 3, int number 4, int number 5. Perfectly fine. We could have done the exact same thing, right, with that. Now, what we couldn't have done is said, hey, user, tell me how many numbers you want to store, and I'm going to hang on to them. And if they said 20, we had no way previously of saying, okay, here's an integer 1, here's integer 2, here's integer 3, integer 4, integer 5, integer 6, 7, and then keep those values around. We could have done them inside of a loop, but they would not have existed outside of that loop. So now we can say, okay, how many numbers do you want to put in here? And we can have them and maintain and store them in a single array or array list object for the entirety of our code. And it can be dynamic, right? You can ask them, hey, how many things you want to enter? They'll tell you whatever they want, right? And we can go for it. So previously we had no good way of doing this sort of dynamic, hey, enter this number of values and keep them. We could have done a loop to do something with them, but if I wanted to keep the values around, we had no option. So this does let us do things that we couldn't have done previously, which is pretty cool. Unlike methods that it saves us a lot of time and effort, but we could have done anything without methods that we could do with methods, that sort of thing. So brand new tool in the toolkit, very powerful. You'll see arrays a lot to do a lot of cool things. All right, we got the rest of tonight. It's midterm prep. There's no current project for us to work on, which is great. And then next week, I'm not planning on showing up unless you want me to come. But I'm happy to if you'd like me to. But we got the midterm to work on, open book, open notes all week long. So there'll be nothing new next week. Just take the time to finish up the midterm, finish up early, take a breath, take some time off if you want. And then when we come back in 2 weeks in November, we'll pick up the files topic and we'll look at the last individual project. Then we'll talk about exceptions. That'll be a light week. We're not going to do a whole lot with them. And then we'll finish up project 4, and then we get into Java FX and our final project. So if you do want to work with somebody, make sure you start getting to know your neighbor and see if anyone wants to collaborate on that final project. If you want to do it individually, that's cool too. I know we're still in the middle of a pandemic, so I won't make you pair up, but up to you folks. Okay? All right, awesome. Let's call that a night. If you folks online have anything for me, hit me up in Discord, email, text, call, that sort of thing. I'll do what I can to help. Hopefully we'll be in good shape for the midterm coming up. All right, take care, everybody.